Hello students. Last week we have tried to discuss on statistics about measures of location and measures of dispersion. Today we'll see about probability of an event, fundamental principle of counting, factorial of a given non-negative integer, permutations and combination. To discuss about probability of an event, we have to remember three terms. Experiment. We have to do an experiment. An experiment, it is an activity which gives result or outcomes. When we are doing an experiment, we have different possible outcomes. The set of all possible outcomes, we call that sample space. And any subset of the sample space, we call it that event. It is an interest of an individual to be successful. Then what is the probability of an event? It is the ratio of the number of elements of the event divided by number of elements of possible outcome. If we take one simple example, when I throw that a coin, I have two possible outcomes. The sample space, it will be a set containing edge and tail, which means head and tail. If my interest is to get the event contains head, what is the probability of getting head when you are asked? You will get that a result, the number of elements of the event divided by number of possible outcomes, which is number of elements of the event 1 divided by number of possible outcomes to be 2. So the probability of getting a head, it is half it will be. When you are coming to the other one, multiplication principle. What is that multiplication principle? If we select an item in any different ways, and another selection can be done in m different ways, then both selections, one followed by the other, can be done in n times m different ways. What does it mean? Assume that a student Abebe has 3 trousers and 5 shirts. In how many different ways can he arrange of himself? In how many different ways can he dress his clothes? So a trouser, he has 4 trousers. In a shirt, he has 5 shirts. 4 times 5 to be equal to 20 different ways. That is what you are calling that fundamental principle of counting. The other, we have to discuss about factorials. What is a factorial? We are defining that if n is an element of natural number, then n factorial, which means the product of the first n natural numbers. N times n minus 1, times n minus 2, times n minus 3, up to 1 it comes. And 0 factorial, it is 1. Remember, students, 0 and 0 factorial are different numbers. 0 factorial is equal to 1. It will help us when we are discussing about some simplification of factorials. The other, when you are asked to arrange objects, some objects arrangements need order into consideration or take order into consideration. Such kind of arrangements, we call that permutations. Some arrangements do not take order into consideration. Such arrangements, we call that combinations. And if n objects are to be arranged, by taking r at a time, we can calculate by using the formula, the permutation of n comma r is equal to n factorial divided by n minus r factorial, where 0 is less than r, less than or equal to n it comes. Here, order, it is taken into consideration. When you are coming to combinations, the number of combinations of n objects taking r at a time without considering the order of selection is given by the combination of n comma r, which is the permutation of n comma r divided by r factorial is equal to n factorial over r factorial times n minus r factorial. most of the students, they made a mistake to identify permutation and combinations. If I give simple example, when there is an athletics competition, everybody is following the competition up to the end. They are watching their television. Why they are looking up to the end? Because the order of the result is very important one, being first, second, third, fourth. So that was order is very important one. It is a type of permutation problem. If there are 3 students in a class, and if you want to give 2 free tickets for any 2 of the students, assume there are 3 students in the class, and you have 2 free tickets to give them. In how many different ways can you do this one? This problem, it is a combination problem, because order has no importance. You can give that for student Abebe and Kabada, or Kabada and Abebe. Both have got their free tickets. Based on this one, I want to give that some activities. Take, for example, number 1. If a number is selected at random from the integers 1 to 10, what is the probability that the number selected is a prime number? Let me give that a minute. What will be the solution? Here we are doing that an activity, selecting a number from 1 to 10. So possible outcome, it was this one. Then you are expecting a prime number. To get a prime number, what is a prime number? It is a number which has 2 factors, 1 and itself. So from this possible outcomes, 2, 3, 5, 7 are prime numbers. So I know number of elements of the sample space. I know the number of elements of the event. Then what will be its probability? The probability of getting a prime number equals number of elements of the event over number of elements of possibly it's a sample space. So you will have a result to be 4 over 10, which is equal to 0.4. See the next question. A die is rolled once. A die is a cube, which has 6 faces. On each faces we have different dots. On the first face, 1 dot to mean number 1. On the second face, we have 2 dots to mean number 2, and so on. The last face 6, it has 6 dots over it, on it. Find the probability that it is even or it is divisible by 3. It is even or divisible by 3. So we have 2 events here. Sample space, it is total possible outcome of your experiment, your activity, that is throwing a die. But when you are throwing a die, I have 6 possible outcomes. Then let us see events. We have 2 different events. Event 1, getting even number, which is multiple of 2, 2, 4, 6. Event 2, it is divisible by 3. So 3 and 6 are numbers which are divisible by 3. But event 1 and event 2 have a common element, which is number 6. Then how do you find its probability? The probability of even or divisible by 3, it was equal to the probability of event 1 or event 2 it comes. Then when you are following the step, probability of event 1 plus probability of event 2 minus their common element. So you will get a result. The probability of getting even number, there are 3 even numbers that should be divided by total possible outcome. You have event 2 divisible by 3, we have 2 elements. So 2 divided by 6 minus their common element. We have only 1 element, 1 out of 6. When this one is simplified, it gives a result to be equal to 2 over 3. So this was, I think, a probability problem also. Take the third one. How many different 2-digit numbers can be formed using the digits 3, 5, 6, and 9 if a digit is used only once? Only once means you cannot repeat the same digit twice in a given numeral. So how many different two-digit numbers can be formed using these digits? Let me give you that 1 minute. To do this problem, we are given that for possible per two-digit number, we should have tens place and units place number. For the tens place, you can select any one of these 4 digits, 3, 5, 6, 9. So for the tens place, we have 4 possible choices. Since a digit cannot repeat, one of the digits it is used for the tens place, say number 3. When I use that number 3, 3 digits left. So for the units place, we have 3 digit possibility choices. Or if you are taking that 9 as the 10th digit, for the units digit, we have to select from the remaining 3 possibilities. So this could be done that the first place selection, the 10th place selection can be done in 4 different ways. Whereas the units place selection can be done in 3 different ways. So 4 times 3 gives 12. I can prepare 12 different two-digit numbers using these 4 digits. What does it mean, that one? 35 is 1. 36, 39, two-digit numbers beginning with 3. 53, 56, 59, again beginning with 5. 63, 65, and 69, beginning with 6. Beginning with 9 as the 10th place, 93, 95, 96. That is the total numbers which are listed over here. Here, don't miss, students. I am not saying that 33 is not a two-digit number. It definitely is a two-digit number, but we are told to use a digit at most once. At most once. Only once. You cannot repeat. 33 is a two-digit number when the digit is repeated. 55 is a two-digit number that can be formed, but when you are repeating the digit. So here what you are asked, if a digit used only once. Next, try to find that these values, the factorial of the following numbers. 5 factorial, 8 factorial, 10 factorial over 5 times 7 factorial, 3 plus 2 factorial, the factorial of their sum. The sum of the 2 factorials. What is that? Let's see the solution. A, 5 factorial. By definition, which is the product of the first 5 natural numbers. 5, 4, 3, 2, 1. When these are multiplied, you will get a number 120. Second, B, 8 factorial. It is the product of the first 8 natural numbers. When you multiply it, you will have 40,320. Third, simplify this fraction. 10 factorial over 5 times 7 factorial. 10 factorial could be written, which means that the product of the first 10 natural numbers, which could be written as a product 10 times 9 times 8 times 7 factorial over 5 times 7 factorial. Take care. the factorial, it used only for 7, not for 5, because we don't have a bracket. When these two are simplified, and by 5 we'll have 2. 2 times 9 times 8, it gives a value to be 144. The next one, 3 plus 2 factorial. You have a bracket here. So by applying board mass, first the bracket will be done. 3 plus 2 addition, 5. 5 factorial, what is that? So when I complete, you will get a value to be equal to 120. And the last one, E, 3 factorial plus 2 factorial. It is the sum of 2 different factorials. 3 factorial, you have the product of the first 3 natural numbers. 2 factorial, it was the product of the first 2 natural numbers. This could be added up, 6 plus 2 to be equal to 8. So using ideas of factorial, can discuss about simplification of factorials. And if you see the last 2 exercises, D and E, the factorial of the sum is totally different from the sum of the separate factorials. We are given also for number 5. I will give that 3 minutes. What is the permutation of 6,2? Combination of 8,3. Combination of 4,4. To give solution, you have the permutation of 6,2. In how, what is the meaning? In how many different ways can you arrange 6 objects taking 2 at a time, where order is considered, taken into consideration? So you have the permutation of 6,2 by the formula what you have stated before, 6 factorial, your n, divided by the difference between these 2 values. Simplify it, you will get a result to be equal to 30. Next one, combination of 8,3. 8 factorial divided by 5 factorial into the difference 8 minus 5 factorial. When this one is simplified, you will get a value to be equal to 56. The combination of 4,4. 4 factorial divided by 4 factorial times 4 minus 4 factorial. So the numerator is 4 factorial. The denominator is a product, 4 factorial times 0 factorial. But what we said before, 0 factorial is 1. When this one is simplified, it gives a result to be equal to 1. What is the meaning of combination of 8,3? In how many different ways can you select a committee of 3 from 8 possible choices? Combination of 4,4 can be discussed as, in how many different ways can you select 4 people as a member of a committee out of a total of 4? Number 6, 3 students, A, B, and C, volunteer to serve on a committee. How many different committees can be formed containing 2 students? That means, in how many different ways can you form a committee of 2 members out of 3? The solution will be in. How many volunteer students are there? 3 we are given. What is our M? to form a committee with 2 members. Then in how many different ways can you form? You have the combination of, since committee selection or forming is a combination problem, we have to apply that the formula, the combination of n, r. So what is that? N equals 3, 2 it is a member of the committee 2. So we have to select 2 from 3. 3 factorial over 2 factorial into 3 minus 2 factorial. When this one is evaluated, you will have 3. What does it mean? You can form a committee with 2 members out of 3 in 3 different ways. What is that? A and B could be the member of the committee, or A and C could be the member of the committee, or B and C could be the member of the committee to be. Last question, I will give us the following one. Try to do question number 7. How many different lottery tickets can you prepare using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 with at most 6 digits? To give solution for this one, first we have to make an agreement. 1, have you seen a lottery ticket where all the 6 digits are 0? I think there is no lottery ticket. Second, if I say that 01, 04, 07, how many digit numbers are these? 01, it is a 1-digit number. The leading 0 has no importance. 04, 04 is equal to number 4. It is 1-digit number. If we take 075, 075, how many digit number it is? It is a 2-digit number, which means 75. So what does it mean? When you are preparing lottery ticket, the leading zeros are not considered as a digit place digit. Second, you can repeat a digit to prepare lottery tickets. I may have a lottery ticket, 33,542. 33,542. The 10,000 and the 1,000 places are the same. That means a digit can repeat. So first, you have to distinguish the question what it says. We are going to prepare a lottery ticket using these 10 digits. With these 10 digits, a digit can repeat 1. Second, 0 cannot be taken as a beginning digit. Third, we have to prepare the lottery ticket turn by turn. First, you have to prepare a lottery ticket with 1 digit. You have to take a piece of paper and write on it number 1, number 2, number 3 up to number 9. So we have 9 lottery tickets having only 1 digit. That means from number 1 up to number 9. Next, you have to prepare a lottery ticket with 2 digits. You should have tens place and units place. For the tens place, you cannot use number 0. You have to choose any one of the remaining digits. So for the tens digit, we have 9 possibilities. For the units digit, since a digit can repeat, and 0 could be in the units digit, for the tens place, we have 9 possible choices. For the units place, we have 10 possibilities. By fundamental principle of counting, 9 times 10 to be equal to 90. I can prepare only 92 digit lottery tickets. That means from 10 up to 99. Then you have to come to 3-digit lottery tickets. To prepare 3-digit lottery ticket, I should have hundreds place, tens place, and units place. For the hundreds place, you have 9 possible choices because 0 cannot be. 072, it is 72 what you mean. So you have to choose any one of the 9 digits. So you have 9 possibilities. For the tens place, a digit can repeat. 0 can be included. 102, if I say it, is a 3-digit number. So for the tens place, we have 10 choice. For the units place, again, 10, because we can repeat a digit. When I multiply it, I will have 900 tickets. With 4 digits. 4 digits, you should have thousands place, hundreds place, tens place, and units place. Which digit that you have to put 10,000 place? You have to choose except 0. 9 possible choices. Since a digit can repeat, for the hundreds, tens, and units, you have 10 possible choices for each places. When I multiply, I will get 9,000 tickets. Then, with 5 digits, because we are asked at most 6 digits. For 10,000 place, you have 9 possible choices. 4,000 place, 10, hundreds, tens, and units place, you have 10 possible choices. Any digit can be placed over there. When I multiply this one, I will have 90,000 tickets. Then, the last one. How many lottery tickets can you prepare? With 6 digits. 6-digit number. You should have 100,000 place. For that, except 0, you have to select. You can use any of the digits. Then, for 10,000 place 10, thousands place 10, hundreds, tens, and units place. Except the hundreds digit place number, all other place numbers can be selected in 10 different ways each. When I multiply it, I will have 900,000 tickets. So what you are asked? To prepare a lottery ticket at most with 6 digits. At most with 6 digits. So by calculating turn by turn, you have to take a piece of paper and write the numerals. With 1 digit, 9 lottery tickets. That means from number 1 up to number 9. These are 1-digit numbers. 2-digit numbers from number 10 up to 99. 3-digit numbers from 100 up to 999. 4-digit number from 1,000 up to 9,999. 5-digit number, you have to start from 10,000 up to 99,900 it comes. And for 6-digit number, you have a value to be 100,000 up to 999,999. So when these lottery tickets are added up, you will get total sum that you can prepare. So when you are preparing a lottery ticket, it is a problem which takes order into consideration. So how many lottery tickets can you prepare? With at most 6 digits, when you say, we have to calculate separately and add up, you will get a result 999,999 it will be. Here I am asked, if I buy a ticket, 1 lottery ticket, what is the probability to be successful, to be a winner? This is the total number of lottery tickets that can be prepared. If an individual buys one ticket only, what is the probability of being successful, to be the winner? So you have number of elements of the event, it was 1. Total possible outcome of your experiment is that number. 1 over 999,999 it will be. So I think today we have tried to discuss about probability of an event. To discuss on probability of an event, we have to remember terms. Experiment, it is any activity which gives result or outcomes. When you are doing an experiment, we are expecting different results. The set that contains all possible outcome of your experiment, we call that sample space. Any subset of the sample space, it is called event. So how do you find the probability of an event? It is the ratio of number of elements of the event divided by number of elements of possibility set it will be. So we will get a result. And what you see, the probability of an event do not have a result negative, do not have a result greater than 1. The probability of an event is always a number between 0 and 1 inclusive. If an event has probability 0, we say that event it is an impossible event. If an event has probability 1, we say that event it is certain or sure event. The other what we see, what we have seen, fundamental principle of counting. If one selection can be done in n different ways, and following this, another selection can be done in m different ways, then both selections can be done in n times m different ways. The idea of factorial we have discussed. If n is an element of non-negative integer, then n factorial, which means the product of the first n natural numbers. 0 factorial, it was defined to be is equal to 1. We have ideas of permutation. When objects are arranged, if order is taken into consideration, such arrangement we call that permutations. And you can take that the permutation of n, r can be evaluated as n factorial divided by n minus r factorial. When we are discussing about combination, the number of combinations of n objects taking r at a time can be calculated by using the formula, the combination of n, r, says that n factorial divided by r factorial over n minus r factorial. With this all, we have tried to discuss a lot of exercises in this class. So I will leave the other exercises to do by collecting some problems from your textbook. That is the end of the whole class for today. See you next time.